Hey everyone, it's Mr. Spiels. I'm going to be trying to help you out today and showing you how to find how to use a calculator to find the derivative at a point. And so the example that I chose was actually number 3 from your worksheet earlier today. So if you want to know how to do it by hand or how I got this answer, you can always go look back at the answer key for your worksheet. But we're going to be using, in this video, we're going to be using a TI83 calculator to show how you can really get the same answer at a particular point by calculator as by doing it by hand. So here we have all our work by hand, and for number 3 we said the derivative of this original function is 8x. Okay, so let's think about what that means to have the derivative first before we get to the calculator. So we're at the point 1 comma 5, so we're at the point 1 on our x-axis, and our graph is probably, it's going to be a parabola, so it's probably going to look something like this, right? Okay, so derivative is 8x, but it also depends on what point you're at. So if I'm at where x is 1, the slope of my tangent line is going to be something like this, right? Whereas if I'm all the way over here at like 5 or 6 or whatever, the slope of my tangent line is going to be a lot steeper. I know I'm making a thick line here, but it's going to be a lot steeper. Okay, so your value is all going to depend on what x value you plug in. Okay, so let's try it by hand. My equation for the derivative is 8x. So if I'm evaluating where x is 1, okay, I'm going to plug in 1 for x. Okay, so then the slope of the line at that point, the slope of the tangent line, I should say, at that point is going to be 8. Okay, so again, you can do all this by hand, but quick, let's do a shortcut with a calculator. By calculator, there's 2 ways that you can do this. One is by graphing, and one is kind of on this main screen here. First one I'll show you is by graphing. So first thing you'd want to do is go to your table here and plug in 4x squared plus 1, hit graph. Okay, so that's what the graph looks like, obviously. Now to find the derivative at a point, you'd want to go second trace. Okay, and it's going to bring up this menu. You want to go down to number 6, which is dy dx. And what we want to do is we want to find the value at 1, where x is 1. So I'm going to type in a 1 right here. Okay, all you had to do is type in 1. If I hit enter, I get derivative with respect to x is equal to 8, if you can see it there on my screen. All right, and that's perfect because it matches, it lines up with what we found by hand. Okay, so again, type in your equation, hit your graph, do second trace, find the derivative, type in your value, which is 1, hit enter, and it'll give it to you. Okay, another way of doing this on your main screen, what you have to do is go to math, and what you're going to do is scroll all the way down to, it's called number 8 here, it's called n-deriv. Okay, and what you do when you have n-deriv is you plug in your original equation, 4x squared plus 1, and what you got to use a couple commas here. You want to tell it you're evaluating it with respect to x. So I'm going to put in a comma, x. Okay, now I need to tell it where I'm evaluating it, at what x value. So I'm going to put in another comma and type in a 1, because that's where it's asking me to find it here at sorry, I know I lost you guys at the top there. So I'm looking at 1 right here. Okay, close parentheses. So equation, comma x, comma 1, and there it is. Gives me my value, which is 8, which matches what we did by hand down here. It also matches what we did using the graphing keys. So hopefully these shortcuts help.